Hello, everyone. Let's get started. Please download Laboratory 18 from Blackboard. I received many emails regarding the exercises of Lab 17. So in today's class, I want to show you the right code of the exercises, and yeah, let's discuss it. Okay, so first, please run this script to identify your host name, username, and current information, and input your name, our number, title, and date. Okay. Then please let's get started for the example one. Is the exercise one of the last lab, right? This one. Sorry. This one. Okay. So in this example, we have two bases and thrown ones, and the total numbers as observed. So we need to have a define a function and the simulation to compute the probability. The first one is about the total score is greater than 10. The second one is total score is even and greater than 7. Okay, so the first thing you need to remember is that we need to import the NumPy package as NP. And next one, because here when you are asked to define a function, you need to define a function. Okay, use define and the function name. That's role, and then here is the only one argument. It's called n simulation. N simulation, it means the number of simulation. Okay, and after that we set a like a counter here, counter 0, and then we use a simulation. We use the numpy.array to simulate this dash, right? So it means here we have a list of 1 to 6, and then use the list to create a numpy.array. Then we use it. Then it is a D6 in this example. And after that, we need to define a loop, right? For I in range, the number of the simulation. And these two lines of codes are used to, right, to simulate how to throw D6 once and then again, or you have two dices to, so it means you can simulate it as a throw a D6 twice or throw two dices once, right? Two dices, and then compute the score. It means the total number, right? Total number of these two dices. And after that, you need to find the desired event, right? So here we need to do the conditional selection. If score is greater than 10, then add 1 to the counter. And after that, return this counter divided by the number of simulation. Compute the probability of the desired event by dividing the count by the total number of the trials. Okay, and please make sure here, this is a for loop, right? You can find the indentation here. This structure is a for loop, and after that you get the counter and divided by the number of the simulation is the number of the trials. And please make sure to start the simulation number at least 10,000. Okay, here is at least of 10,000. For instance, if you set only like 100, let's check out. So let's check result 10,000, and then the result would be here greater than 10 after simulation. Rows would be this percent, right? That's right. So you see it's about 8%, right? It's about 8%. You run several times, it's all about the 8%, right? So it means the probability is about 10%, 8%. So you can set it as 100,000. See, you need to maybe wait like 5 more seconds, and 8.3, right? 5 more seconds, 8.2, right? So, and if you set only 100 or only 1,000, let's check result. You see here is only 7%. It's much smaller than expected, right? Because you have you don't have enough cases, so the simulation is not good, right? So you see 8, 6, sorry, 86 or 8, 10. So you see it's much different. But if you said 100, now 10,000, you see it's very stable. I think it's close to 8.8%, right? So the result is more convincing. Yeah, so it's about the first example. And the next one is about the total net score is even and greater than 7, right? So we can do that again. First, we can import the NumPy array and define another function that row 2 and set the argument as the number of simulation, set a counter and use a list from 1 to 6 to create a NumPy array to simulate this D6. And another for loop, right? It's a similar one, and throw these two dices once and get the score, right? Summing them up, and then find if it meets your desire, our desired condition. So for instance, here is the second one. Okay, so make its comments for now, and then you see here if the total number is even and greater than 7, right? So it's greater than 7 and score the remainder of divided by 2 is 0, then and 1, right? So please make sure the logic operator is and, not or any other things. Okay, so and after that, the loop will end and then return the result, set the simulations. Okay, result would be 24. It's about 25, right? 25%. You also set as 100,000. It's very long, right? See, but the result you see is about like 25%. Okay, so here's the first it's the answer to this question, but I see some of you didn't write this. You write this way. It is also right, okay? Because in this situation, if this score, the total score is between 2 to 12, right? The minimum is like a 2 once, so the total score is 2, and the maximum is 2, 6. And then 6 plus 6 is 12. So if the total score is even and greater than 7, so there's only 3 possibilities, only 8, 10, or 12, right? So the result would be 8, 10, or 12. So you can use this logic operator or and count 1. So the result would be like 25% roughly. Yeah, so it's a result. So it is also correct. Okay. The second one. So any questions so far for the first exercises? Okay, next one is about, it's a little bit complicated because here we need to use another way to simulate the data. Here we have like 10 white balls, 20 red balls, and 30 green balls, and we draw 5 balls. Then we need to compute the probability of draw 3 white and 2 red balls. And second one would be we draw 5 balls of the same color. So the first one, you see here, we need to import NumPy and the random, but you can also use the NumPy.random. It's a sub-random from NumPy, but it's fine. I think it's similar. And after that, we define a dictionary. You see a dictionary as D, right? To associate numbers and colors. And after that, we create this dictionary, total of 60 balls, 0 to 60. And then if I is smaller than 10, then we set is white, right? So it means from 0 to 9, the value is white, right? And the key would be the numbers. And the next one, from 10 to 29, the value would be right, and the key would be the numbers. And next one is about green, right? And after that, we set the simulation number and outcome 1. It means the outcome counter here. And do another, create another for loop for I in range, and then create an empty list and use this list to simulate this drawn from the collection, right? So for I in range 5, so it means you need to draw 5 times dot append. Then this one here is because D is a dictionary, right? So and then the square brackets, then the index would be the random number from 0 to 59, and D index would be the value, would be white, red, or gray, right? And then the index number would be randomly selected number from 0 to 59, and then there would be 5 elements, because here we iterate it for 5 times. And you can print the draw here. You can print the draw, and then after that, because draw is a list, right? Square brackets is a list and 5 elements. After that, you can convert the list to a NumPy array. After that, you can use some method from NumPy array. Here, some array is white, so it means it will count the white balls, red balls, and green balls. Okay, because it's this sum is very convenient method in NumPy array. That's why here we do the conversion. Okay, and after that, we need to check the conditional selection. Here, desired event is 3 white and 2 red balls. So we set is white and 3 and red is 2, and set the outcome. If the desired condition is met, with add 1 to the counter, and then after that, show the result. Okay, so let's get started from 100, and let me show you the simulation cases. Okay, so because we print out the list here, you see here the simulation, right? The first case we have 5 elements, white, red, green, red, right? So it's 100 cases, and the result would be 0.0. Yeah, so you see, we don't have any desired cases. 3 white and 2 red, right? There's no one, so that's why here is 0. And after that, we set as maybe perhaps 5,500. It's so long, right? We scroll down. Result will be 0.4. It means only 2, right? Only 2 cases in the 500 cases. Okay, so and then I will comment it off because I want to set it as 10,000. And if we print out all of them, it would be so long in today's notebook, right? So here is only like 0.5%. It's about the first case of example 2, right? And you can also set 100,000, and it will take you maybe 10 seconds or 5 seconds, 10 seconds here, but the result is also roughly 0.5%. So it's a result. Okay. All right, so any questions so far? All right, next one. Next situation is about 5 balls of the same color. Okay, so you can copy most of them, import NumPy, import random, import the and create this dictionary, simulate the data. And but second one, you need to set another outcome counter. We can call it outcome 2. And then you can, the result would be here. I think, let me mark it. All these things is exactly the same as the first example, right? But after that, you need to set a different desired condition. In this one, is the 5 balls of the same color, so you can only write like white is 5 or red is 5 or green is 5, then if this desired condition is met, add 1 to the counter and get the result. Okay. For now, it's 100,000, so it may be take you 5 seconds. It's 3.4, right? Right again. So it will be different because it's only a simulation data. Right, 3.4. 3.7, so it's roughly 3.5, right? So it's the result here. Okay, so it is the answer to the second question. So any questions? Any questions so far? All right. And next one is here's some documents. If you want to read, you can read more, like some document about lab 17, like Monty-Hall, Hall problem, and the probability use Python. And the next one is today's exercise. Here is about also about the probabilities. You go to the market to pick out some gourds to decorate your house for Halloween. You can get 3 randomly choice gourds for $10, and each gourd can either be a orange pumpkin, a green pumpkin, or squash, and the probability of it for each one is 0.6, 0.3, and 0.1. So please answer these 4 questions. Please write codes, okay? Write codes to print out the results. First one is probability of first gourd is a pumpkin. Second one is a green one, squash. And okay, I will check it later. So please write the Python code to print out the results. Okay, and if you are not sure about the last one is a hard one, you can check the codes from lab 17. For instance, you can check here, this one at least 6, right? It's a similar one. So you can check this example to answer the last question. Okay, so it is about today's exercise. Yeah, that's all I want to chat today. And please make sure to finish it and submit by next Monday. And please have a good weekend and a good spring break. Yes, with replacement. Yes, thank you. It's a good question. With replacement, yeah. Check. Let me check your results. Where is it? Okay. Definition of a hard time for I in statement, we can pick. Why do we pick simulation to the what I pick for range? If I'm already got range test. Okay, so it's a good question. Here is a question why we choose this simulation number as the argument, right? Because when you write this this function, there's only like 2. I think you cannot use the dice. So the range dice. So actually here for R in range dice, actually this one could be only a number, right? Range only a start number and the number and the increment. So you can only pass a number here, right? So you cannot pass dash. Dash means 6, right? So if you want to pass 6, then you need to do the random selection, right? So it's not what I want in this example here, because you see in this for loop, and this way, these 3 lines of codes is used to simulate this throwing a dash process, and and how to compute the total number. So I think I'm not sure why you want to use the for I in range depth. If you use that way for I in range depth, it means you want to iterate it for 6 times. 6 times doesn't mean anything, I think, because in this way you need to use the random choice or random int to get some random selections, right? And do the repeat it like here is the like 10,000 times. But if you write for I in range depth, I think you cannot simulate the random process, okay? Because for is only used to like repeat several times, not the random one. Yeah, so that answer your question? I'm not sure it's what you want, it's what you think. Okay, so simulation is used to pick a random, not to pick random. Sorry, I think maybe you understand it wrong. So N simulation is only used to do the like repeat times, how many times you want to repeat. But actually, here the arguments would be something you want to pass from the main program, from the outside program, right? Because you know you want to deal with this one, so deal with this algorithm. So this algorithm is determined, so you can write it inside the function. You don't need to set it as the arguments. So they are settled down, right? Because they're stable, right? So that's why here I choose the simulation number. And then I use the simulation number in for loop. So I think here, range for what I'm picking for the range. Yeah, so if you want to use the range function, the argument of the range function is about how many times you want to repeat. It's nothing related to something you want to randomly select it. So that's why here I use the simulation number, and inside this for loop I use the dice function related to the dice or something else. Yeah, so I think okay. Does that answer your question? Yes, correct. Yes, definitely. Yeah. Amount of times you want to repeating. So that's why here here I revise like 100 and show you the result, right? And the 1,000 and 10,000 show you the different output, right? That's why here, because I can change here, and then I can change the for loops. And for other things, they are all determined for this one, so I cannot change them. So that's why here I only use this as our argument. Okay. Okay, good. Thank you. Yeah, so any other questions? You too. Have a good spring break. Thank you. Yeah.